In this episode, we move from watching the network as a whole to examining what happens on the individual systems that people actually use and depend on every day. Host-based indicators of malicious activity are the signs that appear on a specific device when malware, an attacker, or an unauthorized process begins doing something that does not belong there. For a new learner, this matters because many security problems first become visible on the host itself, even before the broader network picture is fully understood. A host might be a laptop, desktop, server, virtual machine, or other computing device, and each one leaves behind clues when something suspicious takes place. Once you begin recognizing those clues, cybersecurity becomes less abstract and more practical, because you are no longer only thinking about bad things happening somewhere in a large environment. You are learning how a compromised machine starts to look, behave, and change in ways that can be observed, questioned, and investigated before the damage spreads further. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. At the most basic level, a host-based indicator is any sign on a device that suggests malicious activity may be occurring, has already occurred, or is being prepared quietly in the background. These indicators can show up in running processes, new services, altered settings, suspicious files, strange login behavior, or changes to system performance that do not fit the normal purpose of the device. A key beginner lesson is that malicious activity does not always announce itself with a dramatic pop-up, a crash screen, or a ransom note. Often it starts with subtle shifts that only make sense when you compare the current state of the system to what should normally be there. That is why defenders pay such close attention to the host. Even if the attacker uses encryption, trusted applications, or quiet network traffic to avoid attention, the device they are using often still reveals evidence through changes in behavior, configuration, and activity that do not match the system's expected role. It is also important to understand what the word host really means in this context, because beginners sometimes imagine only a standard office computer. In security analysis, a host is any individual system that runs an operating system, stores data, launches processes, maintains logs, and communicates with users or other devices. That can include employee laptops, file servers, application servers, cloud workloads, domain infrastructure, point-of-sale systems, and many other types of endpoints. Each type of host has its own normal behavior, and that normal behavior becomes the reference point for spotting trouble. A workstation used for accounting should not look the same as a web server supporting an online portal, and a database system should not behave like a user laptop. The role of the host matters because what counts as suspicious on one system may be routine on another. Host-based analysis becomes much stronger when the analyst understands not only what changed, but whether that change makes sense for the purpose, ownership, and business function of the specific device involved. One of the clearest categories of host-based indicators involves processes and services. A process is a running instance of a program, and a service is a background function designed to keep performing a task for the system or for users. When malicious code runs on a host, it usually needs to appear as some kind of process, even if it tries to hide or mimic a legitimate one. Analysts therefore pay attention to unusual process names, processes launching from strange locations, unexpected parent and child process relationships, or system tools starting in combinations that do not match ordinary business activity. Services deserve similar attention because attackers often create or modify them to maintain persistence or quietly perform tasks after the initial compromise. A beginner should understand that the issue is rarely just whether a process exists. The real question is whether the process belongs there, whether it started in a believable way, whether it is using resources unusually, and whether its behavior aligns with the host's legitimate purpose. Another important area is file activity, because malicious operations often involve creating, modifying, hiding, or replacing files on the host. A suspicious file in a temporary directory, a newly dropped executable in an unusual location, or a document that suddenly launches unexpected behavior can all be meaningful indicators. Analysts also watch for files that change without a good business reason, especially when the changes affect sensitive data, startup locations, scripts, or critical system components. File names can be misleading, since attackers often choose names that sound ordinary, but the surrounding details can still reveal a problem. A file appearing at an odd hour, being created by an unexpected process, or being copied repeatedly across directories may tell a stronger story than the name itself. For beginners, this is a useful reminder that host-based indicators are often about relationships between events rather than isolated objects. A single file may not look alarming until you connect it to a login, a process launch, a privilege change, or a security alert elsewhere on the device. User and account activity also generate many host-based clues, especially because attackers so often rely on valid credentials after the first stage of a compromise. If a host shows logins at unusual times, repeated failed sign-in attempts, or access under an account that normally never uses that device, those details can matter a great deal. The same is true if an ordinary user account suddenly performs actions that are typically associated with administrative responsibility, such as changing protected settings, accessing restricted directories, or launching system-level tools. A new learner should avoid assuming that a successful login proves safe behavior. Stolen credentials, reused passwords, and session hijacking are common enough that a legitimate-seeming sign-in may still be part of malicious activity. What matters is whether the account, device, time, and actions fit together logically. When they do not, the host is often providing a valuable early warning that someone is using trust in a way the organization never intended. Persistence is another major concept in host-based detection, because attackers often want their access to survive reboots, user logouts, or temporary interruptions. Persistence means establishing a method that allows malicious code or unauthorized control to return later without having to repeat the original compromise method every time. This can happen through startup entries, scheduled tasks, altered services, modified scripts, new user accounts, or changes to system settings that quietly trigger malicious activity in the future. For defenders, persistence indicators are especially important because they suggest the attacker is not just passing through. They are trying to remain in the environment and keep their foothold over time. A beginner should recognize that persistence is less about flashy action and more about quiet preparation. If something on the host has been changed so that suspicious activity automatically restarts or resumes later, that host is not just affected in the moment. It may already be part of a longer-term compromise that will continue unless the underlying mechanism is found and removed. System and application logs are among the richest sources of host-based evidence because they record events that help explain what the device has been doing. These records may show process creation, service changes, software crashes, login attempts, policy modifications, file access, or failures that seem minor until they are placed in context. A beginner does not need to memorize every possible log type to understand the principle. The main idea is that hosts generate histories of activity, and those histories can reveal both sudden incidents and slow-building compromise. For example, a host that shows a new administrative login, followed by a security setting change, followed by an unfamiliar process launch and a series of access attempts to protected files, is telling a much different story than a host showing routine user activity and normal application updates. Logs rarely hand over certainty on their own, but they are crucial because they provide sequence. They allow analysts to reconstruct what happened, when it happened, and how one suspicious event may have led to the next. Performance and stability changes can also function as host-based indicators, although they must be interpreted carefully. A system that becomes unusually slow, runs hotter than normal, crashes unexpectedly, or shows unexplained spikes in processor, memory, or disk usage may be experiencing harmless technical trouble, but it may also be under the influence of malicious activity. Malware often consumes resources while encrypting files, scanning directories, recording activity, mining cryptocurrency, or attempting to spread to other systems. At the same time, analysts must be disciplined enough not to treat every sluggish computer as a security incident. Updates, software bugs, and legitimate heavy workloads can create similar symptoms. The skill is in combining resource anomalies with other evidence. If poor performance appears alongside new processes, file changes, disabled protections, or unusual user actions, the host is becoming much more suspicious. For new learners, this is an important pattern to remember. Technical symptoms become meaningful when they are supported by security context rather than treated as isolated complaints about speed or stability. Security control tampering is one of the strongest host-based indicators because attackers often try to weaken the very protections that could detect or stop them. If antivirus settings change unexpectedly, logging becomes disabled, protection agents stop running, or key system safeguards are altered without approved maintenance activity, that deserves immediate attention. Legitimate administrators do make changes, but those changes usually follow known workflows and should align with real operational needs. When controls are quietly disabled on a single host with no clear business reason, the possibility of malicious interference rises quickly. A beginner should understand that attackers do not only add things to a host. Sometimes they remove defenses, suppress visibility, or interfere with safeguards so the next stages of the compromise can proceed more easily. In many investigations, the most revealing sign is not the malware file itself, but the fact that the host's protections were changed right before other suspicious actions began. That sequence strongly suggests deliberate preparation rather than accidental system behavior. Another valuable category involves configuration and system setting changes that do not fit the normal role of the device. A host may suddenly allow remote access where it previously did not, trust a new application source, change script behavior, alter file associations, or create exceptions that weaken existing policy. These changes can be subtle, and sometimes they are buried in legitimate-looking administration activity, which is exactly why attackers like them. By modifying how the system behaves, they can create new opportunities for control, evasion, or persistence without necessarily dropping an obvious malicious file every time. For a beginner, the key point is that host-based indicators are not limited to visible malware. The host itself may be reshaped to make malicious activity easier later. That means defenders care about what the machine has become willing to do, not only what it is doing at a specific moment. A changed setting may be the clearest sign that someone prepared the system to behave in a riskier way than the organization intended. Host-based analysis becomes far more effective when it takes context seriously, because the same event can be harmless or dangerous depending on where it occurs. A scheduled task on a managed server may be completely expected, while a similar task on a user laptop may deserve review. A new service on a development system may be part of approved testing, while the same service on a payroll machine may be highly unusual. This is why analysts care about asset value, ownership, location, business purpose, normal workload, and recent change history before reaching conclusions. Beginners often worry about memorizing endless suspicious signs, but a better habit is learning to ask whether the observed activity makes sense for that host. If it does not, then the event becomes more interesting. Host-based indicators are really signals of broken expectation. The more clearly an organization understands what its systems are supposed to do, the easier it becomes to notice when one of those systems begins acting like it belongs to an attacker instead. It is also important not to isolate host evidence from the rest of the environment. Some of the strongest investigations begin with a host-based clue and then grow clearer when that clue is compared with network traffic, identity activity, email events, or other records from across the organization. A suspicious process on a laptop may seem uncertain at first, but confidence rises when analysts also see the same host contacting a rare external destination, receiving a phishing message earlier that day, and attempting unusual internal connections afterward. This is one reason why endpoint detection and response, EDR, platforms became so valuable in modern security operations. They help defenders observe host activity more richly and connect those observations to broader patterns of malicious behavior. Even without focusing on specific tools, the lesson for a beginner is simple. Host-based indicators are rarely the whole story by themselves, but they are often the part of the story that reveals what an attacker actually did on the device that was compromised. A practical example can help tie these ideas together. Imagine an employee in human resources opens an attachment that seemed related to a normal work request. Soon afterward, the host shows a newly launched process from an unusual directory. A scheduled task appears even though the user never creates them. Security protections on the machine are modified, and the account begins accessing files at times when the employee is no longer working. The laptop also becomes noticeably slower, and logs show a chain of events that did not exist in its normal pattern the previous week. None of those changes by itself automatically proves a major incident, but together they describe a host that has likely been compromised and is now being used for purposes unrelated to its legitimate role. That is why host-based indicators matter so much. They turn a vague suspicion into a meaningful pattern of changed behavior, allowing analysts to move from uncertainty toward investigation, containment, and recovery with stronger evidence behind their decisions. As you bring all of this together, the lasting idea is that host-based indicators of malicious activity are the signs a device leaves behind when something on that device no longer matches legitimate business purpose. Those signs may appear in processes, services, files, user activity, persistence mechanisms, logs, performance changes, tampered protections, or altered settings that reshape how the host behaves. Their value comes from context, because a host is not suspicious simply for being busy or complex. It becomes suspicious when its behavior no longer fits its role, history, ownership, or expected patterns. For someone studying CySA+, this is essential because real-world analysis often begins with a single machine showing small but meaningful changes that point to something bigger. When you learn to read those changes carefully, the host stops being just a computer on a network and becomes a source of evidence, sequence, and warning that helps defenders detect malicious activity before it becomes a broader crisis.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.